We won't do all of these. Let me see. There are 16 questions. We definitely won't get through all of these today, and there's no reason to. So let me start. But again, if there are types of questions or content that you want to review from the geology and the astronomy, just mention in the chat. Sound good? With that said, let's take a look. Let's skip number 1 and let's start with number 2. We'll just kind of bounce around. Number 2 talks about geothermal energy. And it says that geothermal energy is energy that is extracted from naturally occurring steam or hot rocks in the Earth's crust. It is used in buildings and generate electricity in areas where hot magma or melted rock is close to the surface. In which of these following places is geothermal energy most likely to be used? A, Arizona, a state where abundant sunshine provides solar energy. B, Cape Cod, a peninsula formed from glacial deposits of sand. C, Iceland, an island nation in the Atlantic with active volcanoes. Or D, Saudi Arabia, a Middle Eastern nation with ample oil and gas. All right, well, all that we're really doing here is figuring out which of these 4 places sound like somewhere where there would be potential for geothermal activity. And if geothermal activity is hot water or hot rocks in the Earth's crust that are heated by melting rock or hot magma, right? What do you associate magma with? You associate magma or lava with abundant sunshine or glacially deposited sand? No. But you do associate it with volcanoes, right? You don't necessarily associate magma with oil and gas. So the only answer here that makes any logical sense at all is C, Iceland, right? So sometimes the questions are as straightforward as that, as they seem, okay? Let's go ahead and look at questions 3 and 4. And let's see. They deal with this paragraph and this chart here. And you can kind of take a look at it yourself, but I'll read it as well. So the paragraph says, scientists think there may be more matter and energy in the universe than has been directly observed because of some gravitational effects that cannot be explained otherwise. Dark matter and dark energy, so called that because they do not interact with light, may account for most of the stuff in the universe. In fact, ordinary matter, made up of the chemical elements, may form only 4% of the universe. Okay. So, again, they use the word may a lot in that paragraph because these are theories that are not proven, right? These are just ideas, right? The graph, or the pie chart, shows essentially what the paragraph is explaining, right? Except for in visual terms. They say that of all of the matter, of all the stuff that makes up the universe, it's possible that ordinary visible matter only makes up 0.5% of the universe, and that ordinary non-shining matter makes up 3.5. I don't even actually know what that means. But lucky for us, it probably isn't going to matter. Right? The point of what they're saying is that matter that we think of as being, when we've talked about matter in the past, and we've talked about the stuff that something's made up of, right? That kind of stuff, elements, the periodic table, stuff that is made out of carbon and oxygen and helium, that might only account for 4% of the universe. And the rest could be this dark matter and dark energy. Again, only a theory. Now, let's look at the question. The question says, according to the graph, about what percentage of the universe may consist of matter that does not interact with light? According to the graph, about what percentage of the universe may consist of matter that does not interact with light? Okay, less than 0.01%, 0.5%, 4%, or 26%. This, to me, I'm going to pull out the handy-dandy book because the way I read this seems like either a typo question or a question with a weird answer, right? So let's tackle it together and see if we can't make some sense of it. Because the way I read it, and maybe I'm missing something, and this is one of those times where I'm in the same boat that you are, right? It says dark matter and dark energy are called that because they do not interact with light. So down here, when it says what percentage of the universe may consist of matter that does not interact with light, unless I'm missing something, to me, that would be the majority. That would be this big chunk of dark energy and dark matter, but maybe I'm missing something. So let's find out and see. I've been known to miss things on occasion from time to time. That's why I always like to keep us on our toes and pick some questions I've done and some I've never done. I'm in the wrong, I'm in social studies and not science. Now I'm in the park here. And Serenity, I'm curious to hear what you think on this one. Let's see what the book has for us. I'm just going to go straight to it and see what they say. The book's explanation, and I would protest this as being a pretty faulty question. They say that the answer is D, 26%, because 26% is dark matter. Dark matter doesn't interact with light. But that's a little misleading to me because the way that this paragraph and the way that this chart portray dark energy is that they lump it together and say dark matter and dark energy are called that because they do not interact with light. So when it says about what percentage of the universe may consist of matter that does not interact with light, I would personally think it should be 96. But let me read their explanation and see if it makes any sense to us. It says, according to the passage, dark matter is matter that does not interact with light, and according to the graph, dark matter may make up 26% of the universe. Okay, so I guess the only thing that I could say in justification of this question is 96% isn't an option that they've given us. So by process of elimination, maybe 26% is the best option they give us, but that seems very silly. But again, if you're given that question on a test, the fact that it's a poorly made question isn't going to make it worth any less. You're still expected to get it right, okay? So I suppose what we should have done is rule out A, B, and C because we certainly know that it's not those numbers and that maybe the 26% that matches the dark matter is kind of the best choice we have. Again, very poorly worded question and definitely needs to, I think, be kind of read. Let's look at the next one, okay? Some examples of these questions are good examples and some are bad. That's one I'll have to keep in mind that is particularly bad. Let's hope number 4 is better. And then we'll keep moving on through this. Number 4 says, which of the following statements is a fact rather than a hypothesis about the makeup of the universe? Okay. So again, a hypothesis is another word for an educated guess or an assumption or a theory, right? Those words aren't all interchangeable, but that's essentially what they're getting at, right? So A, dark energy may account for 70% of the universe. B, dark matter may account for 26% of the universe. C, dark energy may cause gravitational effects. D, ordinary matter is made up of the chemical elements. Now, what we talked about earlier, this one's pretty cut and dry. Remember, the fact that they use the word may implies that it might be or that it could be, right? So A, B, and C all say dark energy may be this, dark matter might be this, dark energy may cause this, but it doesn't say definitively dark energy causes this. Dark matter, it accounts for it. It just says it might. So the easy choice here, the right answer is D, that ordinary matter is made up of the chemical elements. Okay? Ordinary matter is the stuff that we know that's made up of the elements that we have classified and discovered. That's straightforward as that. Okay? All right, so let's see if I can find some more exciting questions. Here is an interesting question that looks an awful lot like something we'd see in social studies. And since we talked about geography today, this sounds like a great place to focus for a minute. And proof that on the science test, you might still need to have some geography skills or some social studies skills also, some overlap between these subjects. Okay? So number 5 says, which type of climate is characteristic of areas along the equator? So you have to be able to first identify the different climates. Secondly, identify where the equator is. Third, look and see in that area or that region what kind of climates are most prevalent. That's like the 3 steps we need to follow. So first, we need to know what the different climates are. And that information is in the key. So if I zoom in a little bit, our key tells us that the white, pure white, is polar. The dotted white-gray is temperate or snow. The light gray is desert steppe. The darker gray is tropical, subtropical, and the black is highlands. Okay? So we don't need to necessarily go into explaining what all those different types of climates are, because that's not going to help us answer the question. All we want to know is, along the equator, what type of climate do we see most often? So here's the equator. Again, if we find the equator here, we see a little bit of black, dark gray, a little bit of black maybe, dark gray, dark gray, dark gray, dark gray. So by far the most that we see, or the most prevalent type of climate that we see, is the dark gray, I would say. Would you agree? So that tells us that tropical, subtropical is our answer. Okay. Let's try number 6. Number 6 says, which of the following statements is supported by the information on the map? One of the favorite GED questions there is, right? Which statement is supported by the information? Probably sick of hearing that type of question. A, the continent with the least area of desert steppe climate is Europe. Area of desert steppe. Okay. That looks like it could be true. Okay. Let's go through and look at the rest. B, Australia's climate is entirely subtropical. Okay, so subtropical would be the dark gray. Australia. So we need to find Australia right here. There is some dark gray, but would you say that the entire climate of Australia is that? Definitely not. So B is wrong. C, Africa and South America do not have areas with highland climate. Are there black but is there any of the black highland climate on Africa? And same on South America. So C is also false. And D, only North America has a large temperate snow climate zone. Okay? North America does have a large temperate snow climate zone, but is it the only continent? No, Europe is entirely that, and Asia has a giant portion of that as well. So our first one ended up being our best choice, right? A. Okay, so let's go ahead and do number 7. We're not going to do number 8. Let's do number 7. It says temperate snow climate zones hold only 1/3 of the world's people, yet produce about 2/3 of the world's wealth. Historically, the fact that temperate/snow climate zones have more blank than other climate zones is the most likely explanation for this discrepancy between population and productivity. So, our 3 options are farm output, seasons, or tropical rainforests. And we want to know which one of those 3 things that the temperate snow climate has more of than the other regions. Because it's saying that disproportionately fewer people live in these areas, but wealth is disproportionately greater, right? So what explains that? Farm output, seasons, or tropical rainforests? Okay, well, let's plug them in. Historically, the fact that temperate snow climate zones have more farm output than other climate zones do is the most likely explanation. Farm output seems possible. It's possible that those regions are able to produce more, which leads to more money, right? Okay, let's plug in the next one. Historically, the fact that temperate snow climate zones have more seasons than other climate zones, that's not necessarily true. Right? All the seasons change in lots of different climates. They change differently in different climates, and there's some truth to that statement, but that's probably not a likely explanation for why there's a discrepancy between population and productivity, right? Seasons wouldn't add productivity. And then lastly, tropical rainforests. We know that temperate snow climate zones don't have more tropical rainforests than other climate zones do. That's silly. Tropical rainforests would exist only in tropical, subtropical climates. There is no tropical rainforest in that climate at all. So farm output is your answer. All right, let's find some good questions here. I'm gonna search. Let me make sure that these look before I complete them. Okay. All right. Hopefully you're not sick of these questions yet. Let's. I don't want to do that. Yeah. Let's do 9 and 10, and then we'll skip ahead to the last page and do some off that. Okay. So number 9 and 10 follow this diagram over here, where we have a diagram of a lunar eclipse and a diagram of a solar eclipse. So lunar eclipse is where the moon goes completely into shadow. A solar eclipse is when the sun goes completely black by the moon. Okay. So we need to fill in the blanks using the options below. Based on the diagram, a lunar eclipse occurs when blank passes between blank and the sun. Okay. Let's take a look. Our choices are blank 1, moon, the sun, earth, the moon, the moon's umbra. Okay. Blank 2 says the sun, earth, the moon, and the moon's penumbra. So penumbra and umbra are there. Okay. So again, here's Earth, solar eclipse, here's the sun, the moon blocks it. Lunar eclipse, here's the sun, here's the Earth, here's the moon, and here's the penumbra and the umbra. Okay? So we want to know that based on the diagram that we read, a lunar eclipse occurs when blank passes between blank and the sun. Okay? So let's take a look. Here's the moon, here's the sun. Okay? What's in between the two? Earth. So based on the diagram, a lunar eclipse occurs when Earth passes between the moon, right, and the sun. Makes sense. And based on the diagram, it kind of makes sense. Now, the one thing I don't like about the diagram here is the penumbra and the umbra are just thrown in there as kind of things to trick you. They're not really providing any insight to this question. They're just there to confuse you, right? So there you go. Take it for what it's worth, right? Again, sometimes these questions are easy and sometimes they're A, either difficult or B, confusingly written. So let's look at number 10. Which of the following statements is supported by the information in the diagram? Okay? During a solar eclipse, the sun passes through Earth's umbra. B, during a lunar eclipse, the sun passes through the moon's umbra. C, a lunar eclipse can only be seen at night, and a solar eclipse can be seen only during the day. Or D, a maximum of 5 solar eclipses and 13 lunar eclipses are possible during each year. I know the first one I'm getting rid of for sure is D. Throwing D out. There's nothing in the diagram that tells me anything about the number of eclipses that. Okay. So I'm picking between A, B, and C. And again, we're looking for which is supported by the information in the diagram. So, the fact that a lunar eclipse is when the moon is obscured by the Earth, right? And a solar eclipse is when the sun is obscured by the moon. The only times that we can see that are at night and during the day, right? Those are the only two times that make sense. So the explanation, the lunar eclipse diagram, indicates a person on the day side of Earth. In other words, if you're over here and it's daytime, you're not going to be able to see the eclipse. Only if you're on the night side of Earth are you going to be able to see the eclipse. Same thing here. If you are in nighttime during a solar eclipse, you're looking the wrong way. You are looking this way. And the people in the daylight are seeing the eclipse happen during the day. So C, based on the information we've got, C is the right one. Okay? All right, let's skip this. This is a writing prompt. We don't need to practice our writing prompts. There is a tiny writing portion on the test, but it's fairly insignificant in terms of how many points it's compared to the rest of it. So we don't even worry about it. Okay. All right. We've got time for a couple more questions. Let me see which ones I want to do. I think I want to skip number 13 and do 14 and 15. So let's look at 14 and 15. Hopefully that's not way too zoomed out. I think I can do all of them. So the diagram is titled The Rock Cycle, so I'm going to scroll way up. Okay, so we can barely get it. Okay, so this is the rock cycle. Our question, so let's look at the question first, and then maybe we'll explain the rock cycle as is needed, right? Fossils can form when plant or animal remains are buried under sand, mud, or silt. These materials can be compacted to form rock. A hiker knew she had found a blank because it contained the fossilized imprint of a fish. So, our answer choices are igneous rock, sedimentary rock, and rocks formed from magma. Okay, so here's magma. Okay. Magma only forms one kind of rock, igneous. Notice the arrow goes this way. Igneous rock is volcanic rock, rock formed directly from magma. Okay, so it's not that. Okay? I would get rid of rock formed from magma. We know that's not the case. It says fossils can form when plant or animal remains are buried under sand, mud, or silt. Okay, so there's your first guess, your first hint. Where do you see sand, mud, and silt mentioned on this diagram? Here, metamorphic rocks, sedimentary rocks, igneous rocks, or sediments. Okay. Sediments. Sediments are sand, mud, and silt, and they lead to the formation of, follow the arrow, sedimentary rocks. Sedimentary rocks are rocks formed from sediment. So, because they found a fossil in that rock, the hiker knew that she had found a sedimentary rock. That makes sense? And lastly, what is magma? A, melted rock, B, crystallized rock, C, cooled rock, or D, eroded rock? Okay? Kind of a silly question here. Hopefully should be easy. Sedimentary rocks, arrow going to magma, burial and melting. Same thing, burial and melting, burial and melting. So basically, it doesn't matter what type of rock, could be any of the three types, igneous, metamorphic, or sedimentary. Rocks get buried and melt and then become magma, right? Which then in turn can turn into igneous rock. All three types of rock can get buried and melt and turn into magma. So the right answer is just A, melted rock. Okay. And then our last question, I'm gonna have to keep my eyes on this or remember this. There are some silly questions in here, actually. Hopefully still. All right. Number 16 says, in open pit mining, surface layers of soil and rock are stripped to obtain coal, ores, or minerals. It is cheaper than shaft mining because there is no underground work. Which of the following is the most likely reason that some countries restrict open pit mining? So again, most likely. So just using our logic, what do we think could be the reason why some countries restrict? Because the paragraph says that open pit mining is cheaper than shaft mining because there's no underground work, but it also says that in open pit mining, surface layers of soil and rock are stripped to obtain those minerals. So let's look at our answer choices. A, there are no underground deposits. B, open pit mining is more dangerous than shaft mining. C, open pit mining destroys valuable land. Or D, open pit mining yields low-grade coal, ores, and minerals. Okay? So, again, which of these is most likely? We're just kind of making the best guess we can. Well, I'd throw out A, there are no underground deposits. Open pit mining versus a shaft mining, it's still accessing the same minerals. They're still underground. And open pit mining is just basically, if here's the mineral and here's the surface, and open pit mining is just saying, we're going to scour everything down to the minerals so that it's open, right? But it still begins underground. The deposits are always underground. regardless of what type of mining we're using. So A is the first one. D is probably the other one. Open pit mining yields low-grade coal, ores, and minerals. Again, the grade or the quality of the coal or ore or mineral is the same. It doesn't make sense that it would be worse or better because it's just a different way of accessing the same thing. Okay? A and D are the first two I'd throw out 100%. But if we look at B and C, let's see which one makes the most logical sense. B, open pit mining is more dangerous than shaft mining. C, open pit mining destroys valuable land. Right. What do you think? We don't know for sure. Either of these answers could be true. But my gut tells me open pit mining probably isn't more dangerous. It's probably less dangerous because you're not having to go underground. Now that could be false, but that would be my guess. My guess would be that B doesn't quite make sense because in my head, at least, shaft mining seems more dangerous. And on the flip side, C says open pit mining destroys valuable land. Well, think about if here's your mineral, is it going to destroy more land to just basically dig a hole and make a tunnel down to it? Or rip away everything around it just to get to that mineral, right? You're going to destroy a lot more land. So my guess, my gut tells me that C makes the most logical sense, and that's true. C is the right answer. Okay, so again, some of these questions were helpful or were good, some were less good. That one was really bad, but again, hopefully some of these practices and these techniques were somewhat helpful. Monday, we will start up a new topic entirely, going through the life sciences section, which is a big chunk of the test. Like the majority of the questions that you'll get on the test are going to be life science. So it's a big portion of the test. And that would just be basically biology. We'll kind of go over all of that starting on Monday. So that's all I've got for today. You have a good weekend, and I will see you back here on Monday for class. All right. Have a good one, everybody.